When we think about parallel universes, we often imagine vast, alternate realities. But what if I told you that these alternate realities might exist on a much smaller scale? Today we're diving into the fascinating link between quantum mechanics and the multiverse theory to explore whether parallel universes could exist in the quantum realm within every subatomic particle. Quantum mechanics is one of the most mind-bending fields in all of science. It describes the strange and seemingly random behavior of particles at the smallest scales of reality, particles like electrons, photons, and quarks. But these tiny particles don't just follow the same logical rules we see in our everyday world. Instead, they seem to obey their own strange laws. And some scientists believe that within these rules might lie evidence for parallel universes existing right alongside ours. To understand how parallel universes might work in the quantum world, we need to talk about two fundamental concepts: superposition and uncertainty. In the strange world of quantum mechanics, particles like electrons can exist in multiple states at once. Imagine a single electron. It could be here, there, or somewhere in between. In fact, until we observe it, it exists in all these possible positions simultaneously. This phenomenon is known as superposition. Another concept in quantum mechanics is uncertainty. According to the Heisenberg uncertainty principle, we can't know both the position and momentum of a particle with absolute precision. The act of measuring one of these properties affects the other, which is why particles in the quantum realm seem to behave unpredictably. One interpretation of quantum mechanics, known as the many worlds interpretation, offers a bold solution to this quantum puzzle. Proposed by physicist Hugh Everett in 1957, the many worlds interpretation suggests that every possible outcome for a quantum event actually happens. In other words, instead of choosing a single outcome, the universe splits each time a quantum event occurs, creating a new universe for each possibility. Let's take a simple example. Imagine a particle that could spin either up or down. According to the many worlds interpretation, when we observe the particle, the universe splits. In one universe, the particle spins up. In another, it spins down. This means that, theoretically, there are an infinite number of universes branching out every time a quantum decision is made, each one a separate reality with its own version of events. If the many worlds interpretation is correct, then there could be countless parallel universes existing alongside ours, each one only slightly different based on every possible quantum outcome. This means that somewhere out there, in a parallel universe, there's a version of you who chose a different career or who took a different path in life, or who experienced a different set of events, all because of a split on a quantum level. The idea that every quantum event creates a new reality challenges our perception of a single unified universe. It suggests that reality isn't linear or singular, but rather a sprawling multiverse of branching paths, each existing independently yet linked through the nature of quantum mechanics. Does quantum mechanics prove the multiverse? So does quantum mechanics prove the existence of parallel universes? Well, not quite. The many worlds interpretation is just one way to explain the strange behaviors we see in the quantum world. While it's a popular and intriguing idea, not all scientists agree with it. Some think there are other, less radical ways to interpret quantum mechanics. One alternative is the Copenhagen interpretation, which suggests that particles don't exist in multiple states, but instead remain undefined until observed. This idea, however, has its own issues, especially when it comes to explaining how particles can seem to be in two places at once, or interact with each other instantaneously, even across great distances. Quantum entanglement, a connection across universes. Another strange phenomenon in quantum mechanics is entanglement. Quantum entanglement occurs when two particles become linked in such a way that the state of one particle directly influences the state of the other, no matter the distance between them. Einstein called this a spooky action at a distance, and it's one of the most mysterious effects in quantum physics. Some scientists have proposed that quantum entanglement might suggest a form of connection between parallel universes. Could entangled particles be somehow linked across different realities? While this is a highly speculative idea, it opens up fascinating possibilities about the interconnected nature of the multiverse. One of the most intriguing questions in quantum mechanics is the role of observation. The act of observing a quantum event seems to collapse the wave of possibilities, forcing it into one specific state. But what if instead of collapsing into one state, our observation creates a new branch of reality each time we observe a quantum event? This idea aligns with the many worlds interpretation and implies that consciousness might play a role in generating parallel universes. In other words, every choice we make, every action we take, and every observation we perform might lead to the creation of a new universe, each one a distinct reality formed by the infinite possibilities of the quantum world. Of course, the many worlds interpretation isn't without its critics. One of the biggest challenges is that it's almost impossible to test. Because each parallel universe exists separately from our own, there's no way to interact with these other worlds or even know they're there. This makes it difficult for scientists to gather evidence to support or refute the idea. Another criticism is that the many worlds interpretation creates an enormous number of universes, which some scientists think is overly complex. Why create countless universes when other interpretations could explain quantum mechanics without the need for such drastic measures? Yet for others, the idea of parallel universes feels like a natural extension of quantum theory. So is it possible that we're living in a quantum multiverse? A realm where every quantum decision creates a new universe where every possibility plays out in a different reality? While we may not have definitive answers, the concept of a quantum multiverse reminds us of the vast unknowns within our reality. As we continue to study the quantum world, we're forced to rethink our understanding of existence. The idea of parallel universes challenges us to consider that reality might not be a single continuous thread, but a vast branching web of possibilities. A quantum multiverse where every choice, every action, and every quantum event creates a new world. What do you think about the possibility of parallel universes existing at the quantum level? Do you believe each quantum decision creates a new reality? Let us know in the comments below, and don't forget to subscribe for more mind-expanding explorations into the unknown.